Okay, another day, another video. In today's video, we're going to build an end-to-end JWT-based Vapor server. I was intending to do a GraphQL server, but the GraphQL libraries as part of Vapor are not ready for prime time. So we're going to have to hold off on that. Before I get started with the coding and stuff, I'll just give a very brief overview of how JWT works and basically what it is. So JWT is intended to do the authorization part of your security system. So for security, you need the two pieces. You need authentication to see who the person is and confirm who the person is that's trying to access your system. And then you need the authorization piece that determines whether this person has access to, API XYZ. So JWT is designed specifically for that second piece, the authorization piece. But in this video, I'm going to show both mechanisms, the authentication piece via username and password, and then the JWT authorization piece. So to get started with JWT, you need to create private keys and public keys. So the way to do that, if you're already running a Mac or a Unix system, then you can use this command to create your private key, and you can use this command to create the public key. I'm not sure exactly how it would work in Windows, but it's more than likely pretty similar. So once you do that, and I've already gone ahead and done that, you can see that the files were generated here in my Vapor project, and I'm going to be making use of them or calling into them from the code. So in order to make use of JWT, we need to add a little bit of boilerplate code, and I'm not going to bother typing this out. And this will look very new, but I'll try to explain it as best I can. So that reminds me. Before you can make use of JWT, you need to import the package. These packages are available in other forms. There's one for Cocoa, but I'm using the Swift Package Manager version. So you have to indicate the package dependency. The latest version is 4.0. And also in your target dependencies, you have to indicate the product. But once you do that, you will be able to do imports. What's going on here? Okay, so there was a delay there. So basically what's going on is you need to configure JWT in the system before you can actually go about using it. Now, the reason for that is the mechanism of how JWT works. So Java Web Tokens, which is what the acronym stands for, is basically a sessionless authorization system. So there is no in-memory store on the server of these tokens or any identifier for the tokens that we are going to be generating. We simply generate the token and then give them to the client, the browser or the Swift app, whatever it may be, and they have to maintain the token, and they subsequently have to pass the token on every single call that they make to an API that requires authorization. So I want to make that super clear. They have to pass the token back on every single call. And the reason for that is because it's sessionless. There is nothing stored or saved on the server in order to keep this session information alive, and therefore it's required that the client return the token back on every call. Now, because these tokens are now living on the client's machine, they are now untrustworthy. They could have been tampered either by the user or by a hacker, and therefore they're not really reliable. Especially in this case because the tokens go back in an unencrypted format. They're encoded, but they're not encrypted. So the way that security is maintained is through these encryption keys. But like I said, instead of being encrypted, what they do is they create a cryptographically secure signature. So the token will have a payload that you determine as the developer, whatever you deem necessary. That could be stuff like the username, maybe the user ID, the role of the user, since we're trying to authorize users to various APIs. And that payload is sent back to the client along with a signature. Because this signature generator is private and maintained only on the server, only the server can generate this signature. And the generation of the signature is also determined by whatever's in the payload. So the net effect of this is that if the user receives the token and they tamper with the contents of the payload, meaning let's say there's a roles claim in there, and then they change the roles. They give themselves greater roles, right? That payload then no longer matches with the signature that was sent over from the server. And the client, the user, the hacker, whatever it may be, does not have access to the key, and therefore they cannot generate a new matching signature. So that's basically how the mechanism works. Okay, so once these things are set up based on these key files that we generated on the command line, they will be associated to the application object under this JWT object. And I'll show you what it looks like to start using these in a moment, but we need to do some setup first. So since this is all configuration related stuff, obviously it makes sense to put it in the configure file. And then the next thing that we want to do is we want to, well, actually, let's do this first. Once the user is authenticated, and again, I'm not talking about authorization, but authenticated with their username and password, we want to be able to pass them user profile type information, right? Now, I'm not going to fill in all of the details of something like that, but let's just say that this is the information that's sufficient for now, right? So I want to create a payload model instead of the entire user model, because there's lots of extraneous and really unnecessary information that can be sent back. Like, for example, the password and the to-dos and stuff like that. Obviously, some of this stuff we could just null out, but regardless, there's no reason to do that. So we're just going to create this payload object here. Now, like I said before, we need to do some setup in order to start utilizing this ability to create signatures. So the way that's going to work is, like I said, this security process is going to be a two-step process. The first one is going to be authentication. So in order to handle the authentication piece, we're going to, I need to import JWT. Is this coming in or not? All right, so that's it. So we need to conform to this protocol. And like I said, this is part of the authentication process. So what we're doing here is we're comparing passwords, the one given to the one that's on the database, making sure that they match. All right. So we're making sure that they match so that we can then allow the user, or we can be sure that the user is who they claim to be. And then the second step requires that we create an object based on this JWT Authenticator. And what's going on here is the authentication will generate the token, meaning the user logging in successfully, which simply means getting past this verify function, is going to allow us to generate a token with whatever information that we need to generate and the privately generated signature. So that's what we're going to send to the user. Subsequent calls, which are authorization calls, are going to receive that token. Like I said before, all calls need to send this token once it's generated. And then those calls will be verified by this object, which is going to be middleware. And I'll show you where this plugs in a bit. So let's create this payload object before we continue. Now this is the actual data that's being sent to the user, and this data can contain anything that we want it to contain, but by default there are certain claims that are available. For example, this expiration date claim. So this signer is going to be one of these that we already added into the application object. So here we're just verifying for expiration that it's not expired. And again, I'll show you the actual usage of this code in a moment, but we needed it in order to create our authorization middleware. So as part of implementing this, we need to implement this function. Now the strange thing about this function is it cannot throw and it returns void. So I'm not entirely sure why it was put together like this, but the effect of that is that you end up returning a success no matter what happens. So even in the case of an exception. I don't think it's a bug, but it feels a little awkward to me. But anyway. So here's the signer that we added previously. So if we pretend that this throwable call was successful, right? And this call is this call, okay, as indicated by the generic type alias that we have here. So payload is this guy. Okay, so then this will verify that the token is not expired. Of course, if you want to, you can have other custom verifications of your own in here, whatever you like. But assuming this verification happens successfully, then what we need to do, and once I show you this, this will also seem a little bit weird, but it will make sense in just a moment. So again, we can't return anything. I mean, it's returning an event loop, but there's no payload in there. So we're not going to actually return anything with this map, but we're going to log in the user if it was successfully found, and then return a void event loop future. So this is middleware that runs on every single route. So again, this might seem strange because we're doing this over and over again. But again, because JWT is sessionless and the tokens are being sent back for every single call that needs authorization, this will happen every single time. So just be aware of that. And it needs to happen such that after this login is successful, downstream calls can get that logged in user. You can either use get or you can use this throwable requires call. But if we don't do the login here, then it will never populate. I really can't type today. Okay. Quick compile. All right. So then the next thing that we want to do is we want to be able to generate these tokens. Now, as I said before, the token is not encrypted, but it is encoded into a serialized string. So this generate token will be returning a string version of our payload, the my JWT payload. So what I'm going to do is, since the payload has a date in it, I want to add some time to the date. So that it will expire later. So in this case, I created a constant in a utils file, but basically it's a week from today. So then after that, we're going to create our expiration claim. Now again, we're going to use the signers. We're going to use the private one so we can generate the proper signature. We're going to create a payload of my JWT payload. Since this is an extension, we have access to the fields. All right, so that compiled successfully. So now our middleware is created. We're able to generate a token. So we're able to do what we need to do for authentication and authorization. So the next thing we're going to do is we're going to create our login function. But I want to kind of fix this up a little bit. Yeah. So let's get rid of these guys. So I'm going to create a new subgroup. So just to be clear, the root domain, localhost, in this case it's 8080, port 8080. So it's going to be localhost port 8080 /users/login. So in here, I'm going to create a post call for this new function called login. Let's just create that here. This function is, it's a little bit involved, not horrendously slow, but and again, we're returning the token as a string, so that's why it's a return of event loop future string. Okay. So I think let's just create this new payload user. So this will be our payload for this call. Type user login. And then we need to get the actual user in order to verify their password off of the database. So we're going to do that based upon the username. So we're only taking one. I'm going to force unwrap. Going to flat map throw. So that we can condense down, if we end up having multiple event loops embedded within event loop futures, then we can condense down into a single event loop future. And also we have the ability to throw inside of this call, which we do not inside of this call. So the first thing we need to do is we need to try and verify the user. Verify, again, we're talking about the password. So internal here, it's from this model authenticatable. Model is indicating anything that is database related. So here we use bcrypt to compare the password. So assuming this was successful, let's put a check if it wasn't successful. But assuming this was successful, I'm going to log in the user. It's probably not particularly helpful, but just as part of going through the process, we'll do that. We can get the user with this call, but it's throwable. If you don't want to throw, there's another call that does the same thing, which is called get. So you can use that instead. So this function is being called from here as a post via the login path. And what we're doing is we're getting the username and password via this new object, payload object that we created. And then we're going to go in and we're going to get the user off of the database. Assuming that the user was found, we attempt to verify their password. If it failed, we throw. If it was successful, we log in, and then most importantly, we generate that token and then we send it to the user. So that is the mechanism of how the user ends up with this token. So then, once they get the token, we want to be able to give them their user profile information. But obviously, if they're getting their own user profile, then we need to do an authorization check. So we're going to use this as a get call, and we're going to put this middleware. So this is the JWT authenticator we created earlier. And again, this call to authenticate will always double check the signature on the token, which is the payload right here, which is of type myJWT payload. But we always double check it, and then we attempt to get the user, and then we add them into the auth object so that downstream calls can use either require or get in order to access that that user object. So, assuming that act was successful, then this call will not throw an exception and it will return the user. So we're going to grab that user. We're going to remap them because, again, I don't want to send the entire user object as a payload. I just want to send the most pertinent and secured information. All right. So now we have our mechanism to log in to authenticate. Once we are logged in, we are now going to be able to authorize based on this middleware and get things like the user profile. In addition to that, since our to-dos are also associated to specific users, meaning a specific to-do has a specific user owner, we're going to update the to-do controller so that it acknowledges that ownership. So again, we're going to add our middleware. So that it always checks on every single call. So all of these calls will be checked. And then if we go into the specific calls themselves, we'll do smallish updates. So obviously here we're getting everything that belongs to the same user. So in the case of the creation of to-dos, we also want to make an association. So we're not going to hard code. We're going to use the actual client-side passed-in username. So then once the user is retrieved, assuming that's successful, we get to pass them into the to-do as the parent, and then we continue to create our to-do. So let's just see if this compiles. All right, what's the problem? All right, so sorry about that. I had a bug in my code. This guy right here. I was trying to verify the password from the database and comparing it against the password in the database. So obviously that's wrong. So let's start the server. Okay, so the server is running. And then we are going to take a look at the client now. And let me just open this up a little bit more. So this client, just like the server, is based on the client from the last video, except I've added all of the code for passing the token, and then a new function for doing the login. So now I've already went and run this a couple of times. So just be aware that in order to save the token on the machine in between restarts, I'm doing it on app storage. So then if I restart the application, then it will take the token, the existing one that was saved, into permanent local storage, and then it will use that to do all of the normal calls that we were doing before. So for example, one of them is, actually this is a newer call, but one of them is to get the user profile. Because if the user has the token, then they have the profile. And then the other ones is to get the user specific to-do list. So I'm going to go through this in detail now, but since this is a vapor video, I'm not going to bother typing everything out because this video is already long enough. So the first thing that it's going to try to do upon load is it's going to try and grab the current user profile information, and it's going to try and grab the user's specific list of to-do items. So if we start from the profile, again, I have a global variable that represents the token. It's saved to permanent storage. So that's what it's using as the token. And then if it doesn't have one, then obviously whatever it sends back will be null and fail. But in this case, it has one. So this guy runs. It goes to the updated URL. It indicates that it's a post. And most importantly, it has the token in the header. So for you guys that are not familiar, because you might not be familiar with HTTP if you're a Swift developer. So basically what's going on is every single request that is sent from a client to a web server and every single request that comes back from a web server will always have some metadata, meaning data about the call itself, that describes the call. So that metadata is put into what's called headers in the call itself. And in this case, we're indicating that, hey, the data that's about to be sent to the server is going to be JSON. Okay. Now, in this case, actually, this doesn't even matter because we're doing a get and we don't even have any JSON payload. So I think this is a remnant from my last call. So you can just safely ignore this. But this guy right here does matter because the token itself, again, by the time it reaches the client, it's a string. It's not an object. Is sent or has to be sent in the header, not as payload. Okay, super important. So it's sent as a string in the header with this bearer prefix, and the header name is authorization. Okay, and it doesn't matter if it's a post or a put or whatever, because like I said before, any call can require authorization. So anyway, this call is made with the proper header. Again, we have a check for failure. And then in this case, we are having a return payload, which is the user's profile coming off of this me object. And then that sets me to me. And then this list to do view. Actually, let's do from the top to the bottom. This display user view is going to go to the store. It's an observable store. And that's our environment object, observable store. And then it's going to go to that me object. And assuming it has some data, again, these token calls can fail, so they're optional. But assuming it has data, it's going to put in that user that last logged in successfully and got a token. On top of that, it tries to get the to-dos. And the to-dos are basically the same mechanism. So again, just ignore this. But we have our bearer token in the header. This is going to be a get request because we're trying to retrieve a whole bunch of to-dos. Let's go to the to-dos. To-dos, the index call, that's this guy. So it's protected by our middleware, JWT bearer middleware. That's all auto logged in, assuming the token was correct. And then the user is gotten, and then the user specific to-dos are retrieved. I'm using a data task publisher to be on the main UI thread. I need to update this as well, but that's not the main point of this video, so let's just move on. So basically, to start, we're running where is it? We're running on this queue, this custom queue. We're going to grab the data. We're going to grab the return, the response, and then grab the data off of it. And we're going to return that. So that's why we're mapping to that. We're going to decode it as an array of to-dos. We're going to go back on the UI thread. We're going to do some cleanup here. And then here we're going to receive the actual data. So this is the to-dos. And then we're going to add it to our published list of to-dos. So then this guy, here it is. So then this guy, based on those to-dos, will populate the UI right here and list out only Dave's list of to-dos. So if I add another Dave to-do, let's make this number 2. We can see it got added, right? Now, if I go and switch to a different user, let's say Linda, then I only get Linda's to-dos. I should be clearing this out, but let's make it super clear. I get only Linda's to-dos. So again, it's based upon the token and not some session state on the server, but the token that's on the client, identifying the user as whoever they're supposed to be, and then that token being verified on the server side. So that's it. As always, if you have some questions, just ask them on my website, DzHaven.com, and thanks for watching.